So let's do a simple example problem. It says, calculate the amount of carbon dioxide produced at standard temperature and pressure by the decomposition of 152 grams of calcium carbonate. Okay, let's do it. And they give us an equation here. So what are they telling us? They're telling us calculate the amount of CO2. They want to know how much CO2 are we going to get. We have CO2 here at the end. It's one of the products. How much of this are we going to get? We're produced at standard temperature and pressure. Standard temperature, 25 degrees. Pressure, 1 atmosphere. By the decomposition of 152 grams of calcium carbonate. That's our solid. That's right here. This is breaking down. How much of this are we going to get? Okay? Alright, so I'm going to just write this again for myself. I quickly put down the equation. I write down what they've told us. 152 grams of this stuff, calcium carbonate. How much of this in volume is what they want to know. How much carbon dioxide? And what do they tell us? They tell us we're at, STP. That is not 25 degrees Celsius. That is 0 degrees Celsius, or 273 Kelvin. My mistake. But we're at 273 degrees Kelvin, 1 atmospheric pressure. So, in order to solve for this, we need to find out what is missing. We need to find out how many moles of this we have in order to solve for our volume. Because they give us a pressure. Remember, PV equals nRT. We have P, we need V, and then we have T and R. And so we don't have N right now. We can't solve for this volume without that missing factor. So if we can solve for how many moles, then we can easily figure out the volume. So what I'm going to do, I'm going to figure out how many moles of this broke down. So I'm going to just set this up. 152 grams calcium carbonate, that's what they give us. And I quickly just found the molar mass. All you do is add up the molar mass of calcium, carbon, and 3 oxygens. And that's 100.9 grams per 1 mole. So I set this up. Grams are on the bottom so that these cancel out. So grams, I divide by 100.9. And I have 1.506 moles of this stuff. Okay? That's how many moles. Now, we're going to set up a ratio because we want to know, well, okay, if 1.5 moles of this breaks down, well, how many moles do we get of this? If we set that up, well, we see it's a 1-to-1 ratio. The coefficients are 1. So just 1 mole of carbon dioxide comes for every 1 mole of calcium carbonate, which means we have 1.5 moles of carbon dioxide. That was pretty simple. So just look at that, put together a molar ratio, and now we have our N. That was what we needed. Now we can set up PV equals nRT. Pressure, 1 atmosphere. Volume, that's what we want to know, equals 1.50 moles. That's what we just solved. That's our N. R is 0.08206 liters atmosphere, Kelvin mole, like usual. And our temperature was standard 273 degrees Kelvin. So make sure these all cross out. My atmosphere here, because we're going to divide that. My moles cross out here, Kelvin here. We're left with liters. And when you times that all through, you get 33.7 liters of carbon dioxide are produced at standard temperature and pressure. Pretty simple stuff.